So we're going to start today with an information item to provide us with the 2016 Regulatory Oversight Report on the use of nuclear substances in Canada, as outlined in CMD 17 M42, M42.A, and M42.B. The public was invited to comment in writing. The Commission received 4 submissions. 3 interveners requested to make a presentation, oral presentation, and were permitted to do so. So I will turn now the floor to CNSC staff, and instead, Mr. Moses, you will make the presentation. Over to you.
Bonjour, Monsieur le Président et membres de la Commission. Je m'appelle Colin Moses et je suis le directeur général responsable de la réglementation des substances nucléaires. Je vous présente mes collègues, Ms. Sandra Mortimer, Program Officer within the Transport Licensing and Strategic Support Division, Mr. Henry Rabsky, Director of Operations Inspection, Mr. Mark Broders, Director of Accelerators and Class II Facilities Division, Mr. Peter Fundrick, Director of Nuclear Substance and Radiation Device Licensing, ainsi que Monsieur Sylvain Faye, Directeur des autorisations de transport et du soutien technique. On est également joint par d'autres membres du personnel de la CCSN qui sont présents dans la salle en appui à l'équipe. Nous vous présentons aujourd'hui le rapport annuel de surveillance réglementaire sur l'utilisation des substances nucléaires au Canada pour l'année 2016. Ce rapport constitue le 7e rapport produit jusqu'à maintenant par la CCSN. Le précédent rapport vous ayant été présenté en septembre 2016. Production of this regulatory oversight report continues to be an achievement for the Canadian Nuclear Safety Commission and a mark of best practice internationally. Following the presentation today, the report will be finalized and published on the CNSC external website. The CNSC regulates the nuclear industry in Canada through a comprehensive program of licensing, certification, compliance verification, and enforcement. The safe use of nuclear substances in Canada is a reflection of licensees' compliance with the Nuclear Safety and Control Act, as well as its associated regulations and specific conditions set out in CNSC licenses. The Nuclear Safety and Control Act, its regulations, and the license require that licensees implement and maintain appropriate programs to ensure the safety of nuclear activities, minimize doses to workers and the public, and minimize any potential consequences of events. Licensees are always responsible for the safety of their operations and activities. For each nuclear industry sector described in this report, CNSC staff conduct inspections, assessments, and reviews to evaluate each licensee's programs, processes, and safety performance. Pursuant to the CNSC's mandate for the dissemination of objective regulatory information, and consistent with our commitment to transparency in our activities, the CNSC publishes a series of annual regulatory oversight reports covering all main sectors of CNSC-regulated activities. You've already heard about the CNSC's regulation of nuclear power plants, and today we will be presenting the CNSC's regulatory oversight report on the use of nuclear substances. Before proceeding any further, I would like to note 4 corrections to the report, which are outlined on this slide. These errata do not impact any of the conclusions of the report, and the corrections will be made to the report prior to its final publication. You will see here an overview of the presentation, which will provide an introduction to the CNSC's regulatory approach to regulating nuclear substances in Canada, a summary of the comments received during the consultation period, and outline the 2016 performance of the industry in 4 key safety and control areas. We will conclude the presentation highlighting our progress on certain key initiatives underway in 2017. So to start with a brief introduction of our work. The nuclear substances industry in Canada continues to operate safely in 2016. CNSC oversight activities, including licensing reviews, technical assessments, and inspections, confirm that licensees in the sector have appropriate safety programs in place in order to protect the health and safety of Canadians and the environment. Further, CNSC staff verified that licensees continue to maintain adequate measures to implement Canada's international obligations. Despite the generally strong performance in the industry, there were 2 events reported in 2016 that involved exceedances of regulatory dose limits, both of which had been previously reported to the Commission. In one case, a nuclear energy worker exceeded the regulatory dose limit for extremities as a result of contamination during the administration of a therapeutic nuclear medicine treatment. The second involved a member of the public exceeding their effective annual dose limit as a result of non-compliances with transport regulations. No adverse health effects were observed in either case, and we'll be discussing these events further later in the presentation. CNEC staff remain committed to continuous improvement and have made a number of improvements to the report from previous years. Further to a suggestion from the Commission last year, the 2016 report includes preliminary information on repeat poor performance of a licensee. In addition, in the interest of continued transparency, we have included a list of all inspections conducted by the CNSC staff in this area as an annex to this report. Finally, consistent with our objective of disseminating information on operational events, CNSC staff have included a summary of events related to the use of nuclear substances in Canada in 2016, along with information on significant events that have occurred elsewhere in the world. For the third year, the CNSC posted the draft report for comments prior to presenting the report to the Commission. The report was posted on the CNSC website and pushed out to subscribers to the CNSC subscription service, which includes all licensees regulated and that are covered by this report. In addition, this was the second year that the CNSC made participant funding available to support the review of the report. Funding was awarded to the Canadian Radiation Protection Association, the Canadian Industrial Radiography Safety Association, the Canadian Environmental Law Association, and the Algonquins of Ontario. CNSC staff were particularly pleased this year to have reached a broader span of interest in our regulation of this sector, and the commenters raised questions in several areas, summarized on this slide. This was an excellent opportunity to provide additional information on our regulatory oversight activities, and has resulted in a number of opportunities to further enhance future editions of this report. Because of the breadth of comments received, CNSC staff prepared Supplemental CMD 17M42B, which provides CNSC staff responses to all comments received. To summarize the themes that came out of the comment period, regarding planning and prioritization of compliance activities, the Canadian Environmental Law Association noted the decrease in number of inspections in 2016. CNSC staff have developed a risk-informed regulatory program that considers the nature of the regulated activity and assigns a baseline inspection frequency that is commensurate with the relative risk of that activity. This serves as the foundation of our annual inspection plans, but we layer on top of this a wide variety of reactive inspections triggered by different factors such as inspection results, compliance history, events, whistleblower calls, and sector performance trends. As a result, the number of inspections and person days dedicated to compliance activities can vary substantively from year to year, and should not be taken as either an increase, a decrease, or increase for that matter, in overall regulatory oversight. In 2016, all high-risk inspections were completed as planned, and there were no substantive changes to our overall regulatory program. CELA also commented on the limited information on environmental protection that was included in the 2016 report. It is important to note that the majority of the activities that we regulate have no impact on the environment. There are no operational releases from a double encapsulated sealed source within a radiation device that goes through a rigorous certification process and is subject to annual leak testing. When licensees work with unsealed nuclear substances, we expect stringent work control measures to minimize doses to workers and the public. Although this has never happened since we have started preparing our regulatory oversight reports, if there were ever to be a failure of these barriers, it would trigger an event report that would be discussed in detail in our regulatory oversight report. As a result, CNSC staff do not agree that there is a need to introduce in the Environmental Protection SCA chapter to further editions of this report. We do, however, recognize that there is an opportunity to better describe these measures and will include this information in future editions of the report. Regarding the transport of nuclear substances, CELA raised questions on requirements for labeling, shipping documents, and emergency response. Our detailed responses are included in the CMD. However, I would like to note that CNSC's regulatory framework in this area follows the IEA transport regulations, which are widely adopted internationally and includes, amongst other things, risk-informed requirements for packaging design and testing, and requirements for shipments while in transport. Our regulations also incorporate Transport of Canada's Transport of Dangerous Goods regulations, which are applicable to the movement of all dangerous goods in Canada. Both the Canadian Radiation Protection Association and the Canadian Industrial Radiography Safety Association suggested different means of presenting dose information in the report. The current format is aligned with the type of information currently collected from licensees and is only one indicator CNSC staff use to assess the adequacy of the radiation protection programs that are in place. This format has proven the most effective at identifying meaningful trends in the industry, although we continue to explore different ways of extracting and presenting the wealth of data that we collect from our compliance activities. The CRPA and CIRSA also recognize the importance of outreach and engagement activities, and CNSC staff remain committed to this as one vehicle to communicate and engage with our stakeholders. In addition, CRPA and CIRSA noted the importance of sharing information on events reported to the CNSC. Staff have made a number of improvements in that regard and will continue to explore means to share this information with licensees. Finally, the Algonquins of Ontario requested additional opportunities to engage with the CNSC on our regulatory activities. CNSC staff will continue our engagement with the AOO, providing information on a regulatory framework and exploring which specific facilities and activities within their traditional territory are of interest to their membership. The CNSC's participant funding program is flexible and can assist the AOO to meet with staff, participate in CNSC reviews, participate in monitoring programs, and to conduct Indigenous knowledge and traditional land use studies that will bring value to the Commission. Before turning the presentation, I would like to note that CELA suggests that our report presents an overly optimistic picture of industry performance. I can assure you that is not the case. Our report presents the facts of our oversight. The data collected from inspections are presented as they were observed in the field, and the full list of all events reported to the CNSC is included. Our report objectively discusses the trends that we've extracted from this data. The conclusions are borne out when you look at the year-over-year performance of the industry and the totality of our regulatory oversight. In particular, the dose data clearly shows a gradual reduction in occupational doses received by nuclear energy workers. Taking into account the totality of our regulatory oversight activities, with due consideration to the trends presented in this report, staff are confident on the conclusions presented. I'll now turn the presentation over to Ms. Sandra Mortimer to provide an overview of the industry we regulate.
Good morning. I'm Sandra Mortimer, a Program Officer in the Transport Licensing and Strategic Support Division. In this section of the presentation, we provide an overview of the different activities covered in the report. Nuclear substances and prescribed equipment are used in a broad range of applications that can be grouped into 4 sectors: the medical sector, the industrial sector, the academic and research sector, and the commercial sector. The written report provided detailed information for compliance statistics and doses to workers down to the level of subsectors. However, in today's presentation, the information will remain at the level of the sectors. In 2016, there were 470 licenses in the medical sector. There were over 9,800 individuals working in this sector. 2/3 of these workers are designated as nuclear energy workers, or NEWs. Nuclear substances and prescribed equipment are used in the medical sector in nuclear medicine for both therapeutic treatments and diagnostic procedures, as well as research studies, for radiation therapy and veterinary nuclear medicine. The industrial sector is the largest of the sectors covered in this regulatory oversight report, both in terms of the number of licenses and the number of workers. 58% of the licenses held for activities covered in this report are in the industrial sector. In 2016, there were over 43,000 total workers. Nuclear energy workers represent only 28% of workers in the industrial sector. Many industrial applications of nuclear substances do not require workers to be considered as nuclear energy workers. Only those with the potential to receive doses above 1 millisievert must be registered. Activities in the industrial sector are varied. They include, for example, the use of portable nuclear gauges, which are gamma and neutron emitting devices for measuring density, compaction, and moisture in civil engineering, fixed nuclear gauges in manufacturing facilities and refineries where sealed sources and radiation devices can monitor process flow rates in pipes, fill levels in bottles, or thicknesses of materials being manufactured as examples. Industrial radiography using gamma-emitting sealed sources in devices for non-destructive testing of materials, such as welds on pipes or concrete in buildings. And finally, oil well logging, which lowers specialized gamma and neutron emitting devices into drill holes to map out geological characteristics. The academic and research sector involves the use of nuclear substances and prescribed equipment in teaching and research applications. In 2016, less than 10% of all licenses for the use of nuclear substances and prescribed equipment were in this sector. Over 7,200 workers worked in the academic and research sectors, 37% of which were designated as nuclear energy workers. The academic and research sector includes laboratory studies, which primarily involve the use of unsealed nuclear sources for academic and biomedical research. It also includes licenses for consolidated use of nuclear substances that are granted to institutions such as hospitals and universities where both unsealed and sealed nuclear substances may be used, and which have in place an internal system of permit approvals. In 2016, there were 247 licenses held by users in the commercial sector. This was 11% of all licenses. In this sector, there were approximately 1,900 total workers, of which 73% were designated as nuclear energy workers. The commercial sector encompasses a number of licensed activities related to the production, processing, storage, and distribution of nuclear substances, the calibration of radiation detection equipment, and the servicing of radiation devices and Class II prescribed equipment. The CNSC maintains regulatory oversight of the use of nuclear substances and prescribed equipment by licensees in all Canadian provinces and territories. This slide shows the location of licensees in all 4 sectors. In 2016, there were over 2,000 licenses held across the country. For clarification, as it's difficult to discern on this slide, in the Yukon, Northwest Territories, and Nunavut, the licensees are all from the industrial sector. 42 licenses were held by companies based outside of Canada. These are primarily servicing licensees that come to Canada to perform work on devices owned by Canadian licensees. The number of licenses issued by the CNSC for the use of nuclear substances and prescribed equipment continues to decrease. This is primarily due to consolidation of licensees' business activities, economic conditions, and advancing non-nuclear technologies. In 2016, there were 2,233 licenses held by 1,584 licensees. Doses are monitored for all workers involved in activities authorized by the CNSC. In 2016, there were over 62,000 persons working in the areas covered by this report, the majority of whom worked in the industrial sector. A worker who, in the course of their occupation, performs duties that may result in a dose greater than 1 millisievert per year must be designated as a nuclear energy worker. In 2016, 36% of all workers were designated as nuclear energy workers. Similar to how licensees are located across Canada, the CNSC has staff located in different regions of the country to provide regulatory oversight and support to licensees in all parts of Canada. The Directorate of Nuclear Substance Regulation has staff located in Calgary, Alberta, Mississauga, Ontario, Ottawa, Ontario, and Laval, Quebec. In 2016, the CNSC conducted 1,452 inspections of licensees using nuclear substances and prescribed equipment. Last year, more than 12,600 person days were dedicated to the core CNSC activities of licensing, certification, and compliance of nuclear substances and prescribed equipment. The breakdown to each activity is shown on this slide. When a request for licensing or certification is made to the CNSC, staff review the application and perform a technical assessment of the request to verify that all regulatory requirements have been met, and that the applicant has in place adequate measures to protect health, safety, security, and the environment. A peer review of the assessment is conducted. Once the peer review is complete, the designated officer makes a decision on each request based on staff's evaluation and recommendation, and ensures that all requirements of the Nuclear Safety and Control Act and its regulations are met. CNSC staff continue to lessen the administrative burden on licensees and improve our efficiency through consolidation of licenses where appropriate and by reviewing our internal licensing processes. Industrial radiography involves the use of nuclear substances in exposure devices for non-destructive examination of materials. Under the Nuclear Substances and Radiation Devices regulations, licensees are required to only allow CNSC certified personnel and supervised trainees to use exposure devices. In 2016, the CNSC certified 115 new exposure device operators and renewed the certification of 340 exposure device operators. Licensees have the primary responsibility for safety. All licensees must have in place radiation protection programs. These are evaluated by CNSC staff during the application stage or when changes to the program are made, and are assessed during compliance activities throughout the course of the license. Radiation safety officers, or RSOs, are individuals responsible for implementation of the radiation protection programs. Licensees that operate Class II nuclear facilities or that service Class II prescribed equipment must have certified RSOs. A detailed presentation on the radiation protection programs and the role of the RSO will be presented later today in CMD 17M44. Most decisions related to the regulatory oversight of the use of nuclear substances and prescribed equipment are made by designated officers. As you can see on this slide, designated officers made a total of 2,805 licensing and certification decisions in 2016. Licensing decisions accounted for the majority of these. Looking at the decisions on the certification of prescribed equipment, compared to 2015, there was a notable increase in the number of decisions related to the certification of prescribed equipment. This was due to an increase in the number of expired certificates that were originally issued in the early 2000s. This trend will continue into 2017 before returning to normal levels in 2018. Turning now to the certification of exposure device operators, or EDOs. The number of decisions related to the certification of exposure device operators continues to increase. The number shown on the slide, the 455, includes both new certifications and renewals. While the number of new EDO certificates has remained stable, the increase in the number of certification decisions in 2015 and in 2016 is attributed to the CNSC's gradual implementation of a new expectation for EDOs to renew their certification every 5 years. It is expected that the number of EDO certifications will remain similar to the level in 2016 for the coming years. Now we move to the topic of packaging and transport. Every year, approximately 1 million packages containing radioactive material are transported safely in Canada. The packaging and transport of nuclear substances is regulated jointly by the CNSC and Transport Canada. Transport activities and any packages that are used for transport must comply with CNSC's Packaging and Transport of Nuclear Substances Regulations 2015, Transport Canada's Transportation of Dangerous Goods Regulations, and the International Atomic Energy Agency's regulations for the safe transport of radioactive material. References to packaging and transport made within this presentation or in the regulatory oversight report itself, for example in reference to reported events, are made in the context of activities covered by this report, namely the transport of nuclear substances and prescribed equipment. The CNSC compliance program is risk-informed, planned, and responsive. CNSC inspectors conduct inspections of licensees at defined frequencies over the period of the license. Inspections that are planned but not performed are tracked for inclusion in the next planning cycle. Most inspections of nuclear substance and radiation device licensees are Type 2 inspections. Type 1 inspections may be conducted for licensees that operate at multiple geographic locations or use a combination of unsealed and sealed substances and radiation devices. These Type 1 inspections are above and beyond those performed at Class 2 facilities, which form part of the baseline inspection program for Class 2 licensees. The nuclear substance and radiation device licensees subject to Type 1 inspections are determined for each year based on a risk-informed process taking into account the nature of the activities performed by the licensee, the nuclear substances used, and past compliance history. For all other licensees, Type 2 inspections are the default inspection type and are inspected on a risk-informed inspection frequency. A complete list of all inspections conducted in 2016 and whether or not they were Type 1 or Type 2 inspection is included in Appendix E of the Regulatory Oversight Report. This was a new feature of the 2016 edition. Compliance activities include more than just inspections. The CNSE compliance program also involves reviewing the submissions from licensees, including the review of annual compliance reports for each licensee, the assessment of procedures submitted by licensees, for example, servicing procedures, and the review of events reported to the CNSE and their corrective actions. The results of all compliance activities are documented and non-compliances are tracked until they are addressed by the licensee to the satisfaction of CNSE staff. Repeated performance below expectation leads to increased regulatory oversight, which could include reactive inspections or an increased inspection frequency. Of the 1,452 inspections conducted in 2016, there were 48 cases where licensees who received an SCA grading of below expectations or unacceptable had also received ratings below expectations or unacceptable on the same SCA in their previous inspection. Enforcement actions are taken by the CNSE to compel licensees to comply with regulatory requirements. When CNSE staff find a licensee in non-compliance, they use a graduated approach to bring the licensee back into compliance and deter future non-compliance. CNSE staff have a range of tools available to them, including orders, administrative monetary penalties, and licensing actions. The most appropriate enforcement action is selected and applied based on risk-informed decision-making. In 2016, CNSE staff issued 14 orders and 8 administrative monetary penalties, or AMPs, to licensees covered by this report to address concerns for safety and security. Consistent with previous years, most enforcement actions were issued to licensees in the industrial sector. Concerning the orders issued, once CNSE staff were satisfied that licensees met all terms and conditions of the order was closed. All 14 orders issued in 2016 have been closed. All 8 AMPs issued in 2016 have been paid. In 2016, the designated officer refused to renew 4 licenses, refused to authorize the transfer of 1 license, and in another case, changed the terms and conditions of the license to be more restrictive. CNSE staff continue to engage stakeholders through outreach activities held across Canada. This slide shows the sectors targeted by different outreach activities through the year 2016. Activities included information sessions and webinars for all uses of nuclear substances and radiation devices, the DNSR newsletter, participation in working groups such as the CNSC CRPA Working Group and the CNSC Industrial Radiography Working Group. CNSC staff gave presentations at conferences and industry meetings, for example, at the Canadian Organization of Medical Physicists annual meeting and the British Columbia Funeral Association meeting. And it included workshops focused on particular sectors or activities, such as the portable gauge workshops. Outreach activities are one venue the CNSE uses to inform licensees of regulatory requirements and expectations, and are also a venue for sharing operating experiences. In addition to outreach with the licensed community, CNSE staff continue to engage and connect with their peers in the federal government, including counterparts at Transport Canada, the Public Health Agency of Canada, the National Energy Board, Health Canada, and the community of federal regulators. Furthermore, CNSE staff continue to be engaged at the international level on matters concerning the use of nuclear substances and prescribed equipment. At this time, I'll pass the presentation over to Mr. Rabsky.
Good morning, members of the Commission. My name is Henry Rabsky, Director of the Operations Inspection Division in the Directorate of Nuclear Substance Regulation. Through the following slides, I will be providing an overview of the safety performance of nuclear substance licensees for 2016. For the purposes of the reporting in the Regulatory Oversight Report, the following four safety and control areas, or SCAs, have been selected as they provide a general overview of the licensee's performance: management systems, operating performance, radiation protection, and security. Overall, licensees continued to demonstrate adequate performance within all safety and control areas, as the majority of inspected licensees in 2016 were found to be compliant in the four SCAs covered in this report. More details on these safety performance measures is provided in the following slides. Overall, doses received by nuclear energy workers remained low in 2016, with most workers receiving less than 0.5 millisieverts per year. In 2016, no nuclear energy workers received whole body doses above the regulatory limit of 50 millisieverts. Note that the data from 2012 was obtained by a sampling of workers. Data from 2013 and 16 used all the information that was submitted through the ACRs, the annual compliance reports, by licensees. The management system SCA includes the processes and programs put in place by licensees to achieve their safety objectives and that foster a healthy safety culture. Overall, 97.8% of all inspected licensees showed a satisfactory rating for this safety and control area in 2016. The most common non-compliances in this SCA included conducting activities contrary to a license condition, failure to comply with regulatory requirements related to having records at work locations, and a failure to notify the CNSC of changes in contacts for licensed activities. Please note that 2 licensees received unacceptable ratings for this SCA, and both received an order as a result of the inspection performed. It is too early to speak to trending for performance within the management system SCA at this time, as 2016 marked only the second year this SCA was reported on as part of the Regulatory Oversight Report. CNSC staff will continue to analyze the compliance data for this SCA in future years to monitor for any emerging trends and report them. Moving now to operating performance, which refers to the licensee's ability to perform license activities in accordance with pertinent operating and safety requirements defined in the Nuclear Safety and Control Act, its associated regulations, and license conditions. Licensees are expected to demonstrate that they comply with the operational and safety requirements by providing workers with appropriate procedures for the safe use of nuclear substance and provide prescribed equipment, by ensuring that workers follow procedures, and by maintaining records that demonstrate compliance. 87% of licensees inspected received grades that were satisfactory or fully satisfactory in 2016. As shown in the table this year, 5 inspections conducted within the industrial sector resulted in an unacceptable rating for this safety and control area in 2016. In all cases, an order was issued to ensure that corrective actions were taken immediately. The majority of non-compliances in this safety control area included failure to comply with regulatory requirements related to the retention of records, worker obligations, sealed source leak testing. In all cases, licensees address these non-compliances to the satisfaction of the CNSC. Overall, compliance in this SCA dropped slightly in 2016 compared to the previous year, but remained within the range observed over the last 5 years. The one sector that showed a year-over-year improvement in 2016 was the academic and research sector. Moving now to radiation protection, which requires licensees to establish programs to ensure that contamination levels and radiation doses received by workers are monitored, controlled, and maintained below regulatory limits, and kept at levels that are as low as reasonably achievable, social and economic factors being taken into account. Licensees are expected to monitor worker doses, post radiation warning signs, plan appropriately for radiological emergencies, manage oversight of operational activities, institute effective workplace practices that emphasize the use of time, distance, and shielding, to minimize exposure to radiation and use appropriate protective equipment. All sectors demonstrated adequate performance within the safety and control area, with 84.5% of inspected licensees who received a satisfactory rating. In 2016, for the second year in a row, a decrease in the performance by the medical sector has been observed. In response to relatively lower compliance in this SCA, staff started a project to review the oversight processes for radiation safety officers who are appointed and the radiation protection programs put in place to identify factors that may lead to greater success in implementing effective radiation programs. This initiative will be described in more detail in a presentation later today. The majority of non-compliances reported involved survey meters not being calibrated, inadequate implementation of measures to ensure that doses are kept as low as reasonably achievable, and improper posting signs at boundaries and points of access. In all cases, licensees address these non-compliances to the satisfaction of the CNSC. As we see in this slide, 4 licensees, all in the industrial sector, received unacceptable ratings for this SCA. Note that these same 4 licensees also received unacceptable ratings for the operating performance SCA and all received an order. Finally, security, which requires licensees to have in place physical security measures, practices and programs to prevent the loss, illegal use, illegal possession, or illegal removal of nuclear substances during their entire life cycle, including while they are in storage or during transport. The extent of security measures required depends upon the type of nuclear substance being used and activities performed by each individual licensee. All sectors show satisfactory rating for this safety and control area in 2016, with 93.6% of inspected licensees having ratings of fully satisfactory or satisfactory for this SCA, a small decrease from last year's report. One inspection was given an unacceptable rating and resulted in the issuance of an order to ensure that corrective actions were taken immediately. Licensees as a whole addressed and corrected all non-compliances related to security identified during inspections to the satisfaction of the CNSC. The performance in this safety control area decreased marginally in 2016 compared to previous years. This is attributed to a decrease in the rating in the medical sector. As mentioned earlier, the extent of security measures required is commensurate with the activity of the source. Reg Doc 2.12.3 provided further requirements and guidance for licensees with regards to their security programs. The first phase of implementation of this Reg Doc affected licensees with Category 1 and 2 sealed sources. For these licensees, the expectation for security programs outlined in the Reg Doc came into effect in May 2015. As a result, during the inspections of licensees with Category 1 and 2 sources, CNSC staff verified compliance against requirements described in the Reg Doc. 79% of licensees inspected against these requirements were compliant with all requirements in 2016. The non-compliances cited were primarily administrative in nature and did not impact the immediate security of sources. The second phase of implementation of Reg Doc 2.12.3 will occur in May 2018, impacting licensees in possession of Category 3, 4, and 5 sealed sources. CNSC is proactively reaching out to licensees and clarifying expectations under the Reg Doc that will be coming into effect. For the third year in a row, reported events have been ranked using the International Nuclear and Radiological Events Scale, INES, a tool for communicating the safety significance of nuclear and radiological events to the public. As described in previous years, this tool allows the establishment of a proper perspective of an event's safety significance. The scale has been used to classify events at nuclear power plants since 1990 and has been extended over the years to apply to all nuclear installations. By 2006, it had been adapted to all events associated with the transport, storage, and use of radioactive sources and nuclear substances. Note that the scale is not a tool to compare safety performances among facilities or organizations, but rather to effectively communicate the safety significance of events. The use of the INES scale provides a consistent approach to reporting the safety significance of radiological events. Under this scale, all events are classified on a scale that includes 7 levels. Examples of events that could be rated as level 1 include exposure of a member of the public in excess of the public dose limit, or a loss or theft of a radiation device such as a portable gauge. Examples of events that could be rated as level 2 include exposures to the members of the public in excess of 10 millisieverts, or exposure to a nuclear energy worker in excess of the annual dose limits. CNSC staff review, assess, and track all events reported by licensees. In 2016, there were 139 events reported to the CNSC by licensees in the sectors covered in this report. Of the 139 events, 136 events were ranked as level 0, or no safety significance under the INES scale. One including where a worker sustained an injury not related to the use of nuclear substances. 2 events were ranked as level 1, or anomaly, on the INES scale due to the quantity of nuclear substances involved and the type of event reported. Finally, we had 1 event that ranked as level 2, or an incident, under the INES scale. Note that the events involving missing or found sealed sources are also incorporated into a report that is available on the CNSC website and updated on a regular basis. More information on the 3 events which obtain an INES rating above 0 is provided in the next slides. 2 events related to lost or stolen radiological sources, ranking above INUS level 0. There were 2 instances of theft of a portable gauge where the gauge was subsequently not recovered. For this reason, these 2 events were ranked as level 1 under the INUS scale. These events remain open, and CNSC staff will continue to track any future developments on the identification of the sources. In 2016, there were 2 events of dose exceedances. Both were reported at commission meetings in December 2016. In the first event, a member of the public received an effective dose that exceeded the annual limit of 1 millisievert. The individual received the dose after receiving a ride in a vehicle that was also transporting packages containing nuclear substances. CNSC staff estimate the person received a dose of 1.62 millisieverts. An administrative monetary penalty was issued to the driver of the vehicle. The event was ranked as a level 1 on the INUS scale. The second event occurred when a nuclear energy worker from a hospital received a dose above the regulatory limit of 500 millisievert for extremities. The equivalent dose to the hand was estimated by the CNSC staff to be 1,100 millisieverts. Corrective actions were put in place by the licensee and accepted by the CNSC. This event ranked as level 2 on the INUS scale because a worker received a dose above the regulatory limits. No health effects are expected in either case. Now I'd like to turn the presentation back to Mr. Moses.
Thank you. So before staff conclude the presentation, we would like to provide an update on some of the industry trends that we continue to monitor and highlight some of the work that we currently have underway in 2017. In order to continue to maintain a regulatory program that is robust and effective, the CNSC monitors trends in the nuclear industry and developments in the economic space that may influence the use of nuclear substances and prescribed equipment. Trends of note include industry changes as a result of economic developments, which led to the consolidation of a number of licensees who operate in the oil and gas sector, and increased infrastructure funding, which may lead to the increased use of devices used in construction activities. We've also seen continued interest in new applications of nuclear technologies or improvements to existing technology. For example, with the recent publication of Health Canada's regulations permitting the sale of irradiated ground beef, there is a potential for new irradiation facilities or repurposing existing facilities. There has also been an interest in leveraging this tool for other food or consumable products. Developments in industrial radiography are also of interest. In particular, the industry is exploring the use of small controlled area radiography technology, which mitigates some of the risks associated with industrial radiography. In addition, in the medical field, there is consideration for the construction of proton therapy facilities in Canada, as well as the development of new equipment, such as the Gamma Pod, that has been developed for the treatment of breast cancer. This is on top of the continued development of new probes and labels for medical and research applications. Finally, some applications are finding alternate, non-nuclear tools to meet their needs. For example, the academic sector is adopting alternatives to the use of nuclear substances in research, such as phosphorescence. Also, some low-risk devices are being replaced with technologies that do not require the use of nuclear substances. CNSC staff will continue to monitor these developments in order to ensure that our regulatory framework and oversight remain suitable for the wide variety of applications regulated by the CNSC. While the industry continues to evolve, so does the CNSC. In 2017, we have launched several initiatives to enhance our regulatory oversight, including the development of an initiative for oversight of radiation protection programs for nuclear substances and radiation device licensees, which we'll be discussing in more detail later this afternoon, and enhancements to the Type 1 inspection methodology. In addition, as noted in staff's supplemental CMD, we continue to explore opportunities to better share information and lessons learned from events that have occurred in the industry. Finally, we continue to modernize our regulatory framework and have several related projects underway, including the development of documents to enhance our license and certification application guidance, outline reporting requirements for this sector, and provide expectations in technical areas such as the design of fixed radiography installations and guidance for the safe handling of the deceased. So in conclusion, both as a result of our rigorous licensing and certification reviews and our comprehensive and risk-informed compliance approach, and as evidenced by the continued low levels of exposure across the industry, CNSC staff conclude that the use of nuclear substances in Canada is safe, with adequate protection for the health and safety of persons and due consideration to the security of nuclear substances and prescribed equipment. Thank you for the opportunity to present this report, and we remain available to answer any questions you may have.
Thank you.